In this video, we introduce the concept of a limit using an intuitive approach. We begin our exploration of limits by discussing how to evaluate the limit of a function by inspecting its graph. This video aims to build a conceptual understanding of limits. A function f assigns an output f, x, to every input x. For example, consider the function f, x, equals x squared. If you input 0, the output is 0. If you input 1, the output is 1. If you input 2, the output is 4. If you input 3, the output is 9. Observe that the output of a function changes as the input changes. The limit of the function f at point P describes the behavior of the output f, x, as x moves closer and closer to P. Before going on to the limit, let's take a close look at the movement of x values. Let's pick a point on the x-axis. Say 3. We can approach 3 by starting from the left side of 3 or by starting from the right side of 3. Observe that if we approach 3 by starting from the left, then we walk across the values less than 3. In symbols, approaching from left is denoted by x right arrow 3 and we place a negative sign above 3. Here negative sign indicates the left side. The behavior of the function values or y values as x approaches 3 from the left side is called the left-hand limit at 3 and is denoted by. If we approach 3 by starting from the right, then we walk across the values bigger than 3. In symbols, approaching from right is denoted by x right arrow 3, and we place a positive sign above 3. Here positive sign indicates the left side. The behavior of the function values or y values as x approaches 3 from the right side is called the right-hand limit at 3 and is denoted by.
Okay, let's summarize the results. Definition: left limit. Okay, we write limit of x going to c negative fx equals L and say that left limit of fx is L if the number fx, that is the function value, keep getting close to L as x approaches c from left. Definition of right limit, we write limit c plus fx equal x and say that right limit of fx is L if the number fx keep getting closer to L as x approaches c from right. Okay, this left limit and right limit, we call them one-sided limits. Okay, then I'll introduce a new definition: two-sided limit. We write limit fx equal to c equals L if number fx, the function height, keep getting close to same value L as x approach c from either side. Okay, that means you can come from either side. So this means the two-sided limit is defined only if right limit and left limit are defined and value is equal to L. Okay, now let's go over some examples. Okay, so we are asked to evaluate the right limit, left limit and limit each point. Okay, if the limit is undefined, write undefined. Part A, x equals 4. So here we are asked to find the limits. Okay, so first let us find the to find the right limit at x equals 4, we have to approach 4 from the right side. Okay, so we will start from the furthest point in the right where the graph starts. Here this red dot shows the x value at the furthest point. Okay, so to get the y value, we have to first reach the graph from this point. Okay, so we reach the graph. Okay, and this is the point on the graph. Then we can get the y. We have to reach the y. Now Okay, so this is the x, and then the point on the graph right above x, and its y coordinate. Okay, now let's observe what happens as we approach, as this x coordinates approach 4. You observe the behavior of the y coordinate. Okay, so as x approaches 4, we can see y approach 8. No? As x approaches 4, y approach 8. Okay. To find the right hand side limit, we'll start our motion from the furthest point of the graph on the right hand side. So first we pick the x value. Okay, then to find the point correspond to that x coordinates on the graph, we draw a vertical line. Okay, identify the point where that line meets the graph, and then draw a horizontal line to identify the corresponding y coordinate. Okay, now y coordinate is given by this point. Okay, now as x moves towards 4, we have to check the motion of the y coordinate. Okay, we can see that as x moves towards 4, y is moving towards 8. Now, because right limit and left limit are defined and equal to L, two-sided limit is also defined and equal to L. Function value at x equals 4, f of 4 is 8. It is same as the limit at x equals 4.
Excuse me, sir. So you are muted, sir.
Excuse me, sir. We cannot hear you.
Okay, thank you. Sorry, I muted when I played the video. I forgot. Thank you. Okay, let me see whether the recording is here. Okay, thank you. Also, I turn on the chat. Okay, and okay. So we'll discuss about this section. This is from the lecture notes. Okay. In the last 30 minutes, I will go over those worksheets. Okay, those are just to self-study because you have done those in high school. Okay, so but every week's worksheet, I'll go and answer the last 30 minutes, the questions. Okay, so this is limits and continuity. Okay, this is a new topic. Okay, worksheet වල තියෙනවා මම අන්තිම විනාඩි 30 හැමදාම කතා කරනම් ඒවා self study වගේ. මේක අර lecture note වලින් මේක. Okay, so today we'll talk about this limit and continuity. Okay, so the limit of a function, you saw the definition in the video. Okay, we write limit x goes to c minus fx equals f if the number fx function height keep getting close to L as x approaches c from the left. Okay, so if you think of a graph, if you think of a graph, we have this x-axis and the y-axis, no? So if you have a point, somewhere say 1, x-axis let's say c, I can approach this c along the values less than c or greater than c, no? Okay, our function is going to be like this. So if I approach c along the values less than c, we labeled it by limit x going to c minus. Okay, and when I approach this c, my function value changes with as I go towards c, no? So when it's changed, if I can see it's getting close to some value, we call that value is the limit of the function. Okay, here if it's L1, this situation is L, no? මෙහෙම අපේ දැන් graph එක හිතුවොත් මේ x අක්ෂය අපි point එකක් ගත්තොත් ඒකට අපිට දෙපැත්තකින් ලං වෙන්න පුළුවන් නේ. x මේ c කියන point එක නම් x අක්ෂය, මට c වලට එන්න පුළුවන් c ට අඩු අගයන් දිගේ ඇවිල්ලා. එහෙම එනවනම් මම කියනවා x approaching c මේ ඍණ ලකුණෙන් මෙතන අඩු පැත්තෙන් එනවා කියලා c ට. ඊළඟට c ට වැඩි පැත්තෙන් එන්න පුළුවන් මට c වලට. ඒකට කියනවා limit x goes to c plus fx කියලා. okay, L කියලා. අඩු පැත්තෙන් එනවා නම්. okay, මේ එනකොට මේ අඩු පැත්තෙන් එනකොටත් මේ ෆන්ක්ෂන් එක වැඩි පැත්තෙන් එනවා නම් c plus කියනවා. okay, එතකොට මේ ෆන්ක්ෂන් එක ඒත් ලං වෙන්නේ L ට. නම් L කියනවා. okay, so see when I come from the values bigger than c, I denote it by c plus, and if function is getting close to this, I call it L. Okay, if these two values are same, I can in general say limit x goes to c from either side fx is equal to L. Only if these two are same, no? Otherwise, I cannot tell about this one. This is called the two-sided limit. This is saying when I come either side, it's L. මේ අගයන් දෙක සමාන නම් මට කියන්න පුළුවන් මොන පැත්තෙන් සීටාවත් fx l ට ලං වෙන හින්දා පැත්ත ගැන කියන්නේ නැතුවනේ. මොන පැත්තද කියන්නේ නැතුව මේකට කියනවා two sided limit එක කියලා. Okay. So this one I am not describing the which direction I am approaching C because both of them are same. I can say either side when I approach C is going to L, the common behavior. Okay, these two are called one-sided limit and this is called the two-sided limit. Okay, so we'll look at some examples. Okay, so we have the two-sided limit and one-sided limit, and this two-sided limit only defined if these one-sided limits are defined and equal. Okay, otherwise I cannot talk about the two-sided limit. Okay, so if they are defined and equal to the same value, then the two-sided limit is also L. Okay, මේ one-sided limit දෙකම define වෙලා තියෙනවා නම් ඒ දෙක එකම value එකට සමාන නම් විතරයි මේ two-sided limit එක define වෙලා තියෙන්නේ. ඒකේ value එකත් මේ one-sided limit වලම value එක වෙනවා. Okay, so this is the question example. Okay, in your handout it's example, I guess it's 3.15. Okay, so here this is the one I described in the video. I'll describe it here also. So here it's asked to find the left limit, right limit, and the two-sided limit, left limit, right limit. This two-sided limit also in general we call it limit. Okay, limit, that is the two-sided limit, and the function value at the given point. Okay, මේකදී අහන්නේ one-sided limit උයි limit එක two-sided limit එකට අපි සමහර වෙලාවට limit එක කියලා කියනවා. Okay, so here we can find two one-sided limits. Now first I will start from the left limit. So that means I am approaching here at 4. Okay, so this is 4. So I can approach 4 along the lesser value. Okay, so I will start from this side. Sorry, I will start from this side. So I'll approach 4 from the lesser side. So I'll start from this furthest point. Okay, this is right below here. I start from here and I'm approaching the 4 along the lesser value. Okay, so that I denote by this, no, limit. Okay, I change the color. Okay, change it from here. Pull this down. Okay, so here I denote it by limit. I forgot. Okay, so limit, sorry, okay, sorry, some reason I having trouble. Limit, it goes to 4 minus, no? Fx. So when I getting close to 4, this is the value that goes with the 4, no? Here, if I am here, my value right above the function, this value. Okay, so as I go along, as I approach 4 from this side, when I am moving this x coordinate, point correspond to this point x coordinate is here on the graph, it climbs up, no, along the graph it climbs up, and when I climbs up, the y coordinate goes with that, correspond to that point. That means y coordinate correspond to x, goes along here, and it keep approaching 8, no. So because of that, I can tell this line limit is 8. Okay. මේක මම මේ 4ට ලං වෙනකොට අබ්දු වගේ යන දිගේ මේ x අක්ෂ මෙතන තියෙනවා x coordinate එක. ඒකට corresponding function point එක මෙතන තියෙනවා. එයාට අදාළ y අගේ මෙතන තියෙන්නේ නේ. එතකොට මේක මම මේ x 4ට යද්දි මේ x ට අදාළ graph එකේ point එක graph එක දිගේ උඩට යනවා. ඒත් එක්කම මේ y coordinate එක මේ x ට අදාළ 8ට යනවා නේ. එතකොට this one we call it a. Okay. Then this is the same example you saw in the video. So if I come from the bigger side, when I'm moving here, okay, let's say I start from here and this point and then here. So if I am here, my point is here, no, y coordinate. So as x move towards from the bigger side, also the when my x is going like this, corresponding point on the graph climb along the graph, okay, and y coordinate correspond to that point goes to 8. Okay, so this is also 8. Now two-sided limit is defined, only this one is defined. Okay, therefore the two-sided limit x goes to 4, fx is also 8. Okay, මේක මේ පැත්තෙන් ගියත් 4ට ලං වුණත් මේකට සමාන පොයින්ට් එක ග්‍රාෆ් එක දිගේ උඩට නගිනවා. ඒත් එක්ක මෙයාගේ y coordinate එක 8ට යනවා නේ. එතකොට right limit එකත් 8යි. එතකොට මේ දෙක සමාන වුණොත් two side limit එක මට කියන්න පුළුවන් 8යි කියලා නේ. If they are equal to same value, in general I can say this goes to 8. Okay, then f of 4 is right above the function. Okay, so this is my function value. Function value is point right above 4. This situation, that is also 8, no, right above 4. Okay, any questions? මොනවා හරි ප්‍රශ්න තියෙනවද මේ example එක ගැන? Okay, so it's asked to find the left limit, right limit, two-sided limit, and the function value at the given point. Okay, මෙතන if it's any one is defined, write undefined. Okay, so here I did it at x equals 4. Okay, now we'll move on to this one, example 2. Okay, now here I am asked to find these values at x equals 3. Okay, so I'll do here. So 3 minus fx. Okay, so here, let's say I start from here and work towards 3, okay, along the lesser value. So I'm starting from here and I'm going along this, no? So what happened to if I'm here, point correspond to that point is right above the graph. If I am here, point is here, no? If I am here, point is there, but if I am here, point is here. If I am coming here, point is here. So as I go for towards 3 along the lesser values, point right above it comes down, okay? And then this side it goes towards 4, no? Okay. So the y value when I come here, it's first down, go down, but again go up, okay? So when I'm very close to 3, as I approaches 3, this y value here, no, this part, it goes up to 4, okay? So here again, when I very close values, when I go towards y, what happens? Y value get close to 4. Keep getting closer and closer to 4, no? As I keep get approach 3, as I get close to 3, this y value is getting close to 4 along here, no? So the left limit is 4, okay? So then limit, okay, මේක අපි මම මෙතන 4ට ලං වෙනකොට මේ 3ට ලං වෙනකොට x එක y value එක මේක දිගේ ඇවිල්ලා මෙතන මෙහෙන් මම මෙතනින් පටන් ගත්තොත් මෙහෙම එද්දි යටට ගිහිල්ලා ආයි මෙතනින් උඩට යනවා පොයින්ට් එක. එතකොට මේ අන්තිම හරිය 3ට ලං වෙනකොට මේ y ටික මේ ටිකේනේ. මෙන්න මේ ටිකේ 4ට ලං වෙනවා. එතකොට left limit එක 4යි. Okay. Now 3 plus fx. Can anyone tell me what is this limit? When I come to 3 along the plus values, what is the limit? Can anyone tell me ධන පැත්තෙන් එනකොට limit එක කීයද වෙන්නේ?
5.
Very good. Okay. Let's see. Here we start from here, getting close to 3. From this side, where is my function point? Okay. Thank you for the answer. So here, and I'm starting from here, and this point keep getting closer and closer to here. Then if I draw the y values from here, if I am here, let's change color to this one. Okay. Oh, sorry. If I'm here, okay, if I'm here, this y value is here, no? But if I'm here, y value is here, and then when I go on this portion, I'm on this portion, no? So, and at that portion, I'm getting close to actually 5, no? Because this graph has a jump, no? So, okay, thank you for the answers. Okay, so this one will come close to 5. Okay, 3 plus. Now, what happens to the two-sided limit? I cannot say in general, no? Without a direction, I cannot tell. So that becomes undefined. Okay. Why? Because these two limits are different. Oh, I see. Sorry. Okay. So here, when I come down, it's getting close to 3, it goes undefined. Okay, any questions? So because this part, this side I'm coming along the piece above this piece, no? So this piece, so it's getting close to 5. Okay. So there is one more thing I want to mention. When I find in the limit is decided by this value is very close to this point, no? So I don't have to work from furthest point. I can start from any point and less than 3. So if I'm looking for left side limit, I can start in any point here less than 3 and observe what happens to very close to 3, no? Value is closer to 3. Very close to 3, I have to see what happens. Okay. So because the limit is defined by this behavior of the points very extremely close to 3, no, these points. So as I keep approaches 3, I see as I get closer and closer to 3, what happens to this function y value. Okay. මේක මම මේ ලිමිට් එක හොයනකොට මම මෙහෙම පටන් ගන්න ඕනේ නැහැ. මොකද කොහෙන් ආවත් අන්තිමට ලිමිට් එක ඩිෆයින් වෙන්නේ මේ තුනට ගොඩක් ළඟ තියෙන පොයින්ට්ස් වලින් නේ. එතකොට මට ඕනේ තැන තුනට ලෙෆ්ට් ලිමිට් එක හොයනවා නම් මට අඩු පැත්තේ ඕනේ තැනකින් පටන් අරන් තුනට ළඟම වැලියු වලදී ලං වෙමින් එනකොට y ට වෙන්නේ මොකද කියලා බලන්න ඕනේ. Okay, it's same for this side, no? I can start from any point, and when I get closer and closer to 3, I have to concentrate what happens to the function as I get closer and closer to 3. So it's determined by the values close to 3. So if I'm looking for either limit, I can start from that side. So for left limit, I have to start from anywhere less than 3 on the left side. And for the right limit, I start anywhere bigger than 3 and concentrate on the closer value. Is that clear? Okay. මම හිතනවා ඒක පැහැදිලි ඇති කියලා. ඒ ළඟ values වලට concentrate කරාම ඇති. Okay. So then it asks to us to find the function value at 3. Okay. F3. Now for the function value, we use this notation. So when I come, function value is right above 3, no? Function value is the value right above 3. Now there are two candidates. There is this point is right above 3 and this point is also right above 3. But if I look at this point, it has an open circle. Okay. The open circle means this point does not belong to graph. This one has a closed circle, so it belongs to the graph. So the right above 3, I only have one candidate, this one point, this one. Okay, because this is open, it not belong to the graph. මේ function value එක දෙන්නේ right above 3 තියෙන එකෙන්. හරි, එතකොට මෙතන points දෙකක් තියෙනවා තුනට උඩින්නේ. හැබැයි මෙතන මේ open circle එකක් තියෙන්නේ. ඒකෙන් කියන්නේ මේ point එක graph එකට අයිති නෑ කියලා. හරි, ඒක අඳින්න බැරි හින්දා මෙහෙම ඇඳලා තියෙන්නේ. තුනට එනකන් ඔක්කොම point තියෙනවා, මෙයා නැහැ. හරි. එතකොට මෙයා පාට කරලා තියෙන හින්දා මෙයා graph එකට අයිති වෙනවා. එතකොට තුනේදී limit එක 5යි මෙතන. Okay. Any questions? Okay, now let's go to the next example. Okay, you can try this and send me the answers. I'll give you. Okay, I'll give 5 minutes. Can you send the left limit, right limit, and two-sided limit and the function value here? You can type left limit, right limit instead of, and for the other side, just limit. Okay. So when you send the answers, you can say left limit, right limit, and the limit, and the function value. Okay, you can just type. I'll give you 5 minutes. Send the answers. It's okay to get them wrong. Okay, then I know whether I should explain more or not. Okay, because if you guys already get it, no point to explain further. We can move on to the more advanced ones. Then otherwise we can explain. මම විනාඩි 5ක් දෙනවා ඔයගොල්ලෝ එවන්න මේ උත්තර මේකට මේ මොකද වැරදුනාට කමක් නැහැ. එතකොට මම දන්නවා තව විස්තර කරන්න ඕන කියලා. Okay. Good. Okay. I'll wait few more minutes. Two people answered. Thank you. Okay. Good. Okay. Good. Okay. Not several people are answering. That's help me to see whether you are getting it or not. Good. Okay. Good. Okay. I will start in 2 minutes. Good. Okay. Very good. Okay. Okay. Yeah. So the function value and the two-sided limit. Okay. Yeah. There is one question. So I will explain the previous one and I come back to this. Okay. Someone asked me to explain the function value and the two-sided limit. Oh, okay. So here two-sided limit. So here we are looking for these limits here. These are the definition. Okay. We write fx going to L from right side when we get close to x equals c from the lesser side, that limit is L. Here when x approach c from the uh, right. Okay. So if when I send x to the lesser values, when I approach x x along the left side, values less than c, the left limit is given by this, and if I approach this along the values bigger than c, I say it's the right limit and I write like this, then this is the two-sided limit. Okay. Two-sided limit is defined only these two are equal. then the two-sided limit take the same value because it says common behavior. From either side, x approach c, fx goes to a. Okay, so this one I got limit x goes to c minus fx. This one 4, no? Here I getting 4. Here this one x goes 3. Sorry, here 3, no? 3 fx 5. Okay, so these two are not defined equal. No, they are not equal. මේ දෙක සමාන නැත්නම් two sided limit එක defined නැහැ. Okay, මේ දෙක සමාන නැති නිසා මෙතන අපි direction එකක් දාන්න නැතුව කියන්නේ fx undefined. Okay, undefined here because I approach 3 from one side is 4, other side 5. මේ දෙක සමාන නැත්නම් මේක undefined. මොකද මේක කියන්නේ මොන පැත්තෙන් තුනට ආවත් ලං වෙන්නේ එකම අගයට නම් ඒක තමයි මෙතන කියන්නේ. මොන පැත්තෙන් තුනට ආවත් ඒ අගයට ලං වෙනවා කියලා. ඕකේ, එතකොට මේ දෙක වෙනස් වුණොත් මෙයා defined නැහැ. okay, function value එක කියන්නේ මේ තුනට හරියටම උඩින් තියෙන එක. එතකොට මෙතන graph එකේ දෙකක් තියෙනවා. Okay, so the two sided limit is not defined if these two are not equal. Okay, if they are equal, then two sided limit is defined and equal to the same value because it describe the common behavior. As I approach 3, what happened to the function from either side. So if they are different, I cannot describe the two sided limit. Okay, then the function value is the point right above that value. So here f of 3 is what happens when function value is right above. Okay, හරියටම උඩින් තියෙන එක. So there are 2 points, one of them is not colored. See, this one is not colored, this one is colored. So that means this point doesn't belong to the graph. මෙතන points දෙකක් තියෙනවා තුනට උඩින්. මෙයා open circle එකක්. මේ open එකක්. ඒ කියන්නේ එයා graph එකට අයිති නැහැ. මෙයා උඩ close එකක් හින්දා එයා graph එකට අයිති. එතකොට තුනට උඩින්ම තියෙන්නේ මෙයා විතරයි. මේක open කරලා තියෙන්නේ ඒකයි. එතකොට function value එක හරියටම උඩදී 5යි. Okay, so because this guy is not defined, 5යි. හරි, මොකද මේක නැති මෙයා විතරයි colored වෙලා graph එකේ තියෙන්නේ. මේ point එක නැහැ graph එකේ. ඒ කියන්නේ තුනට උඩින් ඉන්නේ මෙයා, එතකොට 5යි. Okay, so if I go to the next one, people got almost everything correct except for the function value. Good. Okay, but because function value, this notation you have to get used to it. Just so limit x goes to 3 from the lesser side. So I start from here as I go towards 3. Welcome. Okay, so if you go towards 3, this point goes up along the graph and keep getting y value, keep getting close to 4, no? So this limit is the y value. Okay, what happens to the y value as x gets close to 3? So in this graph I can see when I get x close to 3, y value goes up, no, and keep getting closer to 4. Okay, so fx getting close to 4, three plus fx this side, no? When I come to 3 from this side, my y value keep coming down and down and it gets close to again 4, no? Okay, so 4. Okay, මම මේ පැත්තෙන් 3ට ලං වෙනකොට 3ට මෙහෙම ලං වෙනකොට මේ පොයින්ට් එකට අදාළ y එක මේ graph එක දිගේ උඩට නගිනවානේ. මේ පොයින්ට් එක මේ x 3ට ලං වෙනකොට එයාට corresponding graph එකේ පොයින්ට් එක මෙහෙම උඩට යනවා. එතකොට y value ටික එන්න 4ට ලං වෙනවානේ 3ට අඩු පැත්තෙන් එනකොට. එතකොට ඒ ලිමිට් එක 4යි. ඊපස්සේ 3ට වැඩි පැත්තෙන් එනකොට මේ point එක එනවා. එතකොට මේ y value එක 4ට එනවා. Okay. So now because these two are same, I can describe the y value. Okay. Because these two are same, I can describe the two-sided limit from either side. When I get close to 3, fx is getting close to 4. Here I can say a common behavior. මෙතන මොන පැත්තෙන් 3ට ආවත් 4නේ. එතකොට මේ two sided limit එක define වෙනවා. මට කියන්න පුළුවන් මොන පැත්තෙන් 3ට ආවත් මේක 4යි කියලා. Okay. Now the function value, people got it made a mistake there, but that's okay. Okay, because you have to get this note, you used to get this notation. මේ function value එකේ මෙතන 3ට වඩින් hole එකක් තියෙනවා. Sorry, oh, I accidentally press the pen. Okay, so there is a hole right about 3. Okay, so that means this point does not belong to graph, and there is no other point given here. Okay, when a point එකක් දීලත් නැහැ. හරි? එතකොට එතන hole එකක් තියෙන්නේ. Okay, so here there is no hole here and no other point is given. So because of that, this is undefined. Okay, function value undefined. Sorry, keep going for the next one. Undefined. මෙතන function value එක 3ට උඩින් කිසිම එකක් දීලා නැහැ. hole එකක් තියෙනවා, alternating point එකක් දීලා නැහැ. එතකොට මෙතන කියන්නේ function එක එතෙන්දි defined වෙලා නැහැ 3. Okay, මේ point එක graph එකට අයිති නැහැ. This point does not belong to the graph. So there is a hole right about 3 and no value is given. So this function value is undefined, but the limit is defined. Okay. Oh, this is actually I discussed before. Those worksheet will be like now from now on worksheets like review. Okay, I discussed them at last 30 minutes. Okay, last 30 minutes of every class I will go and discuss the worksheets. This one is labeled as the lecture note. Okay, someone asking where you can find this material. So this is labeled as lecture notes. Okay, lecture notes. Okay, because some people need these things for later classes. Okay, so we'll go, otherwise we'll run out of time. Okay, worksheets are that things we discuss in the high school, so it's just to refresh memory. Okay, this is in the lecture note. Okay, so any other questions? Okay, මේ worksheet තියෙන්නේ මේ refresh කරගන්න ඕගොල්ලොට. ඒවා මම හැමදාම ක්ලාස් එකේ විනාඩි 30 ගානේ ඩිස්කස් කරන්නම්. ඒවයින් homework එකට මම ප්‍රශ්නයක් දෙකක් දානවා. ඒ homework වලට දාන ඒවා විභාග වලට එනවා. මේ lecture note එක තමයි අපි mainly යන්නේ දැන්. Okay, so I will put 1 or 2 homework questions from worksheet and we'll discuss those in the class. And if you have any questions, you can ask in the last 30 minutes. From the worksheet, if I assigned as a homework problem, you are supposed to know them for the exam. Okay, if I don't assign homework problems, then that problem just goes as a refreshing. Okay, self-study. Okay. So this is on the lecture note. මේක තියෙන lecture note කියලා මම upload කරලා තියෙන්නේ. Okay, now try this one and send me the answers. Okay. Okay, try this one and send me the answers. Okay, good. Okay, keep. Good. Okay. Good. Okay, good. Good. Okay. Okay, thank you. Okay. Very good. Okay. Okay, good. Okay, thank you for the answer. So here we, oh, okay, very good. Okay. So limit x goes to 3 negative, no? So when I come towards from the lesser side, not negative actually, sorry, lesser side, no? When I approach 3 along the value is less than 3, my function value is going up here and it keeps getting close to 4, no? So this fx, very good, okay? This guy is 4 and limit goes to this guy is also 4, no? When 3 goes here, this guy is also getting close to 4. Okay, then the two-sided limit, they are equal, no? X goes to 3, fx, that is equal to, again, 4, because these two are equal. Okay, and then the f of 3 is 5. Okay, good. Okay, this time almost all the people got it correct. Okay, so මේක මේ පැත්තෙන් 3ට ලං වෙනකොට මේ ලිමිට් එක මේ පොයින්ට් එක 4ට ලං වෙනවා නේ. මේ පැත්තෙන් 3ට ලං වෙනකොට ඒත් මෙහෙම යනවා. එතකොට y අගයන් ආයි 4ට ලං වෙනවා. මෙතන උඩින් 4ට ලං වෙනවා මේ පැත්තේ. මෙයා මෙහෙම වෙනකොට යටින් 4ට ලං වෙනවා නේ. එතකොට මේ දෙකම 4ට සමානයි. මේ graph එක අනිත් පැත්ත තියෙන්නත් පුළුවන් නේ. මෙහෙම අනිත් පැත්ත තිබ්බනම් මෙතනින් එනකොට 4ට ලං වෙනවා. හරි. okay. So f of 3, here there is an open circle. So it does not belong to the graph, but the point above there is a value given. So that is this value. මෙතන open circle එකක් තියෙන්නේ. එයා graph එකේ point එක graph එකේ එයා belongs නැහැ. එතකොට උඩට එනකොට මෙතන පහ තියෙනවා. එයා එතකොට graph එකට අයිති. එතකොට f හරියට මුඩින් තියෙන්නේ 5. So right above x, this is a hole is not on the graph. This point doesn't belong to the graph, but there is a other value given here. This is 5. Okay. So there are two things you want to. I expected you to observe from this exercise. Okay, one, being able to calculate, compute the limit by looking at a graph, and the other one to realize that there is no direct connection in general between the function value at a point and the limit. Okay, if you see first one, all of them are same, no limits and the function value, but second one, limit is not defined. No, we had limit is not defined, but the function value is defined. Okay, and the next one, limit is defined by the function value is not defined. Last one, both of them are defined but they are not same. Okay, මේ exercise එකෙන් මම ඔයගොල්ලෝගේ දෙකක් ඉගෙන ගන්න බලාපොරොත්තු වුණා. එකක් තමයි limit එක compute කරන්න පුළුවන් වෙන එක function එක දිහා බලලා. අනිත් එක තමයි මේ ඔයගොල්ලෝට තේරුම් ගන්න එක මේ function general සාමාන්‍ය function value එකයි limit එකයි අතර connection එකක් නැහැ කියලා. හරි? function value එකයි limit එකයි අතර connection එකක් නැහැ කියලා. මොකද පළවෙනි එක බැලුවොත් ඒ දෙකම define වෙලා තියෙනවා ඒවා සමානයි නේ. දෙවෙනි එකේදී limit එක define වෙලා තිබ්බේ නැහැ නේ. මොකද left to right to වෙනස් නිසා. හැබැයි function value එක define වෙලා තිබ්බා. ඊළඟට මේ C එකේ limit එක define වෙලා තියෙනවා function value එක නැහැ. අන්තිම එකේ දෙකම define වෙලා තියෙනවා ඒ වුණාට ඒ දෙන්න වෙනස්. එතකොට මේ there is no direct connection between function value and the limit. Okay, now we go here. Okay, this is what it says. Okay, this remark is telling what I told you just right now. මේ remark එකේ තියෙන මං කිව්ව එක ඔයගොල්ලෝට දැන් හරි direct connection එකක් නැහැ කියලා. Okay, the next thing we use graph to tell a function value, but here we are using a table. Okay, so here if I look at this table, if I come close to 0, I can see function value is getting close to 2, no, by I can judge. Okay, here I can guess also. Here I can say right value is coming towards 2. Okay, so here if I keep, if this pattern continues, maybe I can make a guess it's getting close to 2. Okay, from the right side and left side, so I can guess the limit may be going to 2. But with these tables I only can guess, I cannot say exactly. Okay, one reason I don't have all the value, it's only I can see this pattern. I hope its pattern is continuing. Okay, මේ table එක දිහා බැලුවම මට මේ හිතන්න පුළුවන් function value එකට guess එකක් කරන්න පුළුවන් දෙකට ලං වෙනවා ඇති කියලා. හැබැයි table එකෙන් හරියටම කියන්න බෑ limit එක අර graph එකේ වගේ. ඒකට හේතුව තමයි එකක් මේ අපි මෙතනින් නවතිනවනේ ඊට පස්සෙත් ඒ pattern එකම continue වෙනවයි කියලා මේ හිතන්න පුළුවන්. එතකොට we can make a guess. Other reason is if we can get these crazy functions. Okay, so if I get a case function, this one function value is limit is undefined. Okay, why? Because when this 1 over x, when x get close to 0, this thing goes to keep getting bigger, infinity, and function try to go up and down crazily. Okay, when it gets close to 0, this function value is crazily going up and down. So here I cannot tell what happened to the function when left limit and right limit are also undefined. මේ function එකේ x බිඳුවට යනකොට left limit එකයි right limit එකයි undefined. ගොඩක් උඩ පහළ යනවා හරි වේගෙන්. එතකොට කියන්න බෑ මොකද්ද වෙන්නේ කියලා. හරි. එතකොට මේක හැබැයි if I make a table using only the stop values, someone might get is getting close to 1. And if I use this stop values, so then people might think limit is going for 1. But if someone make a table only using these below points, you will guess it's going to negative. Okay, so then table is not a very good source. හරි, මේ table එක එච්චර හොඳ source එකක් නෙමෙයි. මොකද මේකේ මේ function එකේ limit එක නැහැ. මොකද මේක ලං වෙනකොට left limit උයි right limit උයි undefined. මේක crazily උඩ පහළ යනවා. x එක බිඳුවට ලං වෙනකොට මේ values ගොඩක් ලොකු වෙනවා. එතකොට මේ crazily උඩ පහළ යන හින්දා කියන්න බෑ left limit එකයි right limit එකයි. හැබැයි ටේබල් එක හදනකොට කවුරු හරි වැරදිලා මේ උඩ පොයින්ට්ස් විතරක් අරන් හැදුවොත් එතකොට පේන්නේ එකට යනවා වගේ ලිමිට් එක. ටේබල් එකේ යට පොයින්ට්ස් විතරක් තෝරගත්තොත් පේන්නේ රින එකට යනවා වගේ. එතකොට ටේබල් එක එච්චර good source එකක් නෙමෙයි ලිමිට් එකට. only guess, we can only guess using the table. Okay, this one right limit is not defined, left මේක right limit left limit උත් define නෑ. Okay, මොකද මේක ගොඩාක් වේගෙන් උඩ පහළ යන හින්දා බිඳුවට ලං වෙද්දී. මොකද මේ as x goes to 0, this one becomes bigger and bigger what the value inside sign. But sign function, if you recall, it's oscillate no between the minus and plus 1. So you cannot tell 1 over sign very close to 0, you cannot tell what happens. Okay, because it goes crazily up and down. Okay, any questions? මොනා හරි ප්‍රශ්න තියෙනවද? Okay, now we'll go for the continuity. Okay, so because of that, so even we cannot we if we have a graph, we can tell the limit. Okay, we can tell the limit if we have a graph. Okay, but if we don't have a graph, it's little bit hard to tell the limit without looking at this definition. Okay, so even if we have a graph, this definition is useful. But if we don't know the graph, then we cannot do. We can, if we given the equation, this definition is not that helpful, because by the equation you can try to make a table, but table is not a very good candidate for not a very good tool for the limits, because of the reason I explained. Okay, so there is another definition for the limits, but you don't. I just listed it for the completeness. If you take a higher math class later, you will discuss another definition for the limit. Okay, so this is not for we. I just listed it. Okay, you don't need to know it for the exam or anything. I just listed it just to say there is another way to another definition for the limits. Okay, I will upload, this thing is missing in the handout lecture note. I will upload a more complete lecture notes today. Okay, from these slides. Okay, මේ limit එක අපිට දැන් මේ මුලින්ම දුන්න limit එක අපිට graph එක දීලා තියෙනවා නම් function එකේ කියන්න පුළුවන්. Okay, graph එක දීලා තියෙනවා නම් function එකේ limit එක කියන්න පුළුවන් මේ definition එකෙන්. හැබැයි graph එක නැත්තම් table එක පාවිච්චි කරොත් අර මං කිව්ව ප්‍රශ්නේ එනවා. එතකොට මේ වගේ crazy graph වලදී මේ limit definition එක ටුට්ටක් අනුව limit ගැන කතා කරන්න අමාරුයි. ඒකින්ද තව advanced definition එකක් තියෙනවා මේ epsilon delta definition කියලා. Okay, මේක ඕගොල්ලෝ දැනගෙන ඉන්න ඕනේ නැහැ, මම නිකන් list කරේ. හරි, මේක මේ මං hand out එක අප්ලෝඩ් කරන්නම් මේ definition එකත් එක්ක. ඒක ඕගොල්ලෝ exam එකට දැනගන්න ඕනේ නැහැ. මේක නම් නිකන් දැනගත් ගන්න ඕනේ නැහැ. මං නිකන් list කරේ ඕගොල්ලෝට එහෙම එකක් තියෙනවා කියලා දැනගෙන ඉන්න. Okay, ඒකට epsilon delta definition එක තියෙනවා. කවුරු හරි interest නම් office hour එකක ඒක discuss කරන්න පුළුවන්. Okay, so you are not responsible for this definition for exams, or even you are not expected to know that, but if you do a later class, you will learn this higher advanced, more advanced math class. I just listed it so you know there is another definition. Okay, but if anyone is interested about this definition, you can ask during office hour. We can set up a meeting. Okay, if anyone need help like office hour, you can email me. Okay, we can set up a additional meeting. Okay, to go one on one. Okay, now we come for the definition of a continuity. Okay, definition of the continuity. So the continuous means in the basic sense, it's saying you cannot have gaps, jumps, or holes in the graph. Okay, so if you look at this one, it's not continuous because there is a jump at 3. Okay, it's continuous at other points, but at 3 it's not continuous because there is a jump. Okay, this one continuous in all the points. Okay, all these from 1 to these all x values is continuous. Okay, this one is not continuous at 3, it's continuous at 1 because there is a jump. Okay, here there is a hole at 3, it's not continuous at 3 but it's continuous on other points. Okay, this is also not continuous in 3 because there is a jump is continuous at other points. මේ continuous කියලා කියන්නේ function එකක් ඒකේ gaps jumps නැත්තම් හරි එතකොට මේක බැලුවොතින් මෙයාගේ jump එකක් තියෙනවා continuous නැහැ තුනේදී අනිත් point වල හැබැයි continuous. Okay, මෙයාගේ තුනේදී hole එකක් තියෙන හින්දා continuous නැහැ. Okay, මෙයාගේ තුනේදී jump එකක් තියෙන හින්දා continuous නැහැ අනිත් point වල continuous. මෙයා ඔක්කොගෙම continuous. Okay, ඔක්කොගෙම continuous මෙයා. Okay, so this definition of continuity tells by theoretically we can check for these continuous. I told you the graph and just the intuitive idea, no gap jumps. This is the definition for the continuity. If function is continuous, fc have to be defined. Okay, and the two-sided limit. Okay, two-sided limit. Okay, continuous means there is no jump. Okay, continuous, there is no jump in the graph, sudden jump. Okay, no holes and no holes and no jump. Okay, so here if I look at here, there's a jump no at 3, so it's not continuous. And this is there's a hole at 3, not continuous, but other points it's continuous, but at 3 there's a hole in the graph, so I have to lift my pencil to draw that. Okay, so here there is a jump. Okay, that is the intuitive meaning. Okay, but the definition says if the limit at a point, two-sided limit is defined and it equal to the equal for the function value. Okay, so left limit, right limit have to be same, and then the two-sided limit is the same thing and the function value is same. If everything is same, then it's continuous. Okay, so that is the definition. So that means what? Fc is defined, x equals c is defined, two-sided limit. Okay, and the limit is equal to the function value. These are the three conditions you will check. Okay, then it is continuous. Is it clear for the person who asked the question now, or do you want me to explain further? Continuous එකේ definition එක ගැන පැහැදිලිද දැන්? Okay, so the everything have to be same, but there is a more complex another definition I will give in a minute. Continuous කියපු එක අහපු එක්කෙනාට meaning of continuous. Oh, sorry, I thought definition. It means there are, I can draw the graph without lifting the pen. Okay, that is the intuitive idea. So if you have a jump, I have to lift the pen, no? Here. Okay, that is the intuitive idea. Okay, good. So now this one, then we have these three conditions. Okay, we have these three conditions. We have Okay, FC means, so this means FC is defines, FC means the function value at the point. Okay, FC means where when I plugging in the function value, this is the two-sided limit when x going to c. Okay, and here this means function value at c. FC means function value at c. FC කියන්නේ function value එක c වලදී plug කරාම එන එක. Okay, so if that is equal to the two-sided limit, then it continuous. Okay, is that clear now? Function FC means the function value at 3. Okay, is it clear now? Okay, good. Okay, so now we will do the same problem. You have to say whether the function is continuous at the point, and then what condition of continuity is going to break. Okay, so here I will do it in other order now, because now I am check function, say for each of the following functions, set whether the function is continuous at the point, also set which condition of the continuity is broken at. Okay, so first I will check for the first condition, FC, no? That means f of 4. Okay, this function f of 4 is 8. Okay, f of 4 is 8, no? Because exactly above the function. Okay, so that is the first condition. Here the first condition is fine, no? Okay, now I go to 2, that is, I have to check whether the two-sided limit is defined. So for that, I have to find each one-sided limit, no? Three, sorry, 4 minus, no? Here I'm going to 4, so 4 minus is equal to 8, no? Eight, limit x goes to 4 plus fx is 8. Now these two are equal, no? So the limit x goes to 4, fx is 8 is defined, no? Okay, so that is defined. So the second condition here is fine. Okay, oh, sorry, second condition is fine. We have to check for the third now, no? This is the second condition. Then the third one, I have to check whether those two are equal. Okay, so we go third, oh sorry, third one, fx equals to f4, no? Because both of them are 8. So f is continuous at x equals 4. This is shortened form for continuous. Okay, so it asks to check for the continuity at 4. This one we already did this, no? මේක අපි කලින් කරානේ f4 8යි. පළවෙනි condition එක හරි. දෙවෙනි condition එක මේ limit එක define වෙලාද කියලා බලන එකනේ. එතකොට දෙවෙනි condition එකේ මේක 8යි, මේකත් 8යි. එතකොට මේ දෙක සමානයි, ඒක define වෙලා තියෙනවා. third condition එකේ මේ දෙක සමානයි නේ. එතකොට ඒකත් හරි, ඒකින්ද conditions තුනම හරි, f එක හතරෙදි continuous. Okay, any questions? Okay, now this one. Okay, this one again, I'm going to go the first one. I look for the first condition, the function value. No, so I'll go f of, we discussed did the this 3 is 5. No, then I check for this one. Okay, now second condition is the limit. First එකේ function value එක check කරා. Second condition එක limit එකනේ. X goes to 3 minus is 4. No, sorry, 4. We just found this one. 5. Now this is undefined. No, x goes to 3, fx undefined. No, because these come into different values. So that means second condition is broken. If one of them broken, I don't have to check for the others because all have to be same. Okay, all have to be whole. Okay, to be continuous. මේක එතකොට එක පහයි මේක අපි කලින් කරානේ මේක මේ දෙක වෙනස් වෙතා limit එක undefined නේ. එහෙම වුණාම second condition එක break වෙනවා. එතකොට තුන්වෙනි එක check කරන්න ඕනේ නැහැ. අපි මේ condition තුනම තියෙන්න ඕන continuous වෙන්න නම්. Okay, so I can say second condition is broken. Oh yeah, sorry, this is 2. No, okay, sorry, this problem I have a typo. I'll correct it because I want to concentrate on this point. Okay, if it was 2 is continuous, sorry. Okay, if it asks for the 2, it is continuous. Okay, I forgot to change the point here, sorry. Thank you. Okay, good. You are paying attention. Okay, okay, if it's continuous at 2 is continuous, because this is 1, this is 1, and function value is 1. Okay, so here I said second condition is broken. I correct it in the when I upload the note. Thank you. Okay, this is supposed to be 3. Okay, f is not continuous at 3. At 3. මේක second එක break කළා මේ දෙකේදී අහුවනම් මේක continuous. Okay, මොකද මෙතනින් එනකොට limit එක එකට උඩින් එනකොටත් එකට function value එකත් එකයි ඔක්කොම සමානයි නේ. Okay, so any questions about this one? No comment. So if one condition is broken, I don't have to check for the next. අනිත් ඒවා check කරන්න ඕනේ නැහැ. Okay, you have to tell which condition is broken because it says state which condition of continuity is broken. Okay, if it's not continuous. If it's continuous, all 3 are held. No. Okay, so these are the conditions. Now can you tell with this one can you send me the answer and tell whether it's continuous or not, which condition is broken. Okay, continuous නැද්ද කියලායි මොන condition එකද break වෙන්නේ කියලායි කියන්නේ. Okay, can you tell? I'll give about 5 minutes. Send the answer whether it's continuous or not, which condition is broken. Okay, is it difficult this one or? So which condition is broken here? Good. Okay, so oh, sorry, again, sorry. This one I forget to change this one, sorry, okay, x equals 3, okay. Sorry, thank you. I think when I copied that problem, I made a mistake. Yeah. So this is again 3, sorry, okay. Send that 3, okay. Sorry, okay. So F3, what, tell whether it's continuous or is it difficult? Very good, okay. Good, okay. Very good, okay. So here, very good, okay. So I can say, okay, here one thing when it's broke, what are the 3 conditions? When first condition is this, no? Second and third, okay, but third condition is the strongest one here. So I would say this, no? F3, if you have this one is okay, F3 is not defined, no? So it's the first condition, no? Third one is also broken, but we don't have to go that far to check because first is broken, okay. First you will understand why I say this when you look at the next example. And also include f is not continuous at 3, okay. Also it say it's not continuous, okay, because good, okay. And so it's the first condition, no, because this is undefined or not defined, okay. See, first condition, it's have to be defined at the point, no. So the third condition you have to check more, but if first condition is broken, we can stop there saying first condition is broken, okay. Then automatically third one breaks, okay, because they cannot be equal. It's correct, the third condition is broken also, but we can stop at saying first condition is broken, okay. When first condition break, third one automatically breaks, okay. But we don't have to go that far. මේකේ first condition එක break වෙලා continuous නෑ. එතකොට third එකත් automatically break වෙනවා. හැබැයි අපි එතෙන්ට යන්න ඕනේ නැහැ. එකේදීම නවත්තන්න පුළුවන්. Okay? මොකද second third, okay, try this one. Now send the answer for this one. Then we go for the, I'll discuss this and go to the worksheet. Okay? Here this one again, okay, this one is 3. මේකේ මොකද වෙන්නේ 3 දී? Okay? Can you tell which condition is broken? Good. Okay. Also say not continuous. Very good. Okay. Good. Okay. So for this answer, first I have to calculate the F3. No. So the first one, F3 is defined. No, because it's 5. Okay. Then second one, yeah, okay, yeah, good. Okay, you can say that, okay. It's continuous at other points. Yeah, very good. Okay. And also say the condition, which condition is broken. Okay. And show that you calculated these limits. Okay, because otherwise, so you have to have these three statements, but you can say it's continuous at other points. Okay. Okay. Is equals 4. You have to show that you check for these. Okay. Not 5, sorry, this is also 4. No? I am just writing because I calculated this before. Okay, මේ දෙකම අපි කලින් කතා කරානේ. 4. Then I say limit select. Yeah, I say limit x is different. This is second condition is also correct. No, first one correct. Then not equals to f3. Okay, so third condition is broken. F is not continuous at 3. Okay, it's continuous at other points. Very good. Okay, but this theoretical explanation of continuity also you should know. Okay, this is the checking for this condition is the mathematical way of saying that there are no jumps. Okay, why we need this mathematical description? Because when it comes to crazy graphs, you need to know. Okay, so then continuity, there is a more rigorous definition. This epsilon delta definition again you will learn it if you take a higher class. Okay, if you take a later math course you will learn this one, but this one is needed because we have these phase graphs, and also if we want to prove certain things we need this definition. You don't need to know this, I just left list it there so you have seen it. Okay, මේ definition එක තමයි mathematically more rigorous definition එකක්. මේක ඔයගොල්ලෝ higher classes ගත්තොත් ඉගෙන ගනි. ඔයගොල්ලෝ දැනගෙන ඉන්න ඕනේ නෑ මේක. ඔයගොල්ලෝගේ even for applications at undergraduate level you don't need to know this. But if you are interested, you can ask me. Okay, if you are a math major, you will do this. But to apply this knowledge, you don't need it. Okay, මේ knowledge practically පාවිච්චි කරන්න මේ definition එක ඕනේ. අර දැන්ට කරපු ටික දැනගත්තම ඇති. හරි? So for use this limit practically in other courses, you don't need the epsilon data. Okay, but if you are interested, you can ask me to do it in office hour. Uh, now, any questions? Okay. So for example, B, let's say B, yeah, it's not continuous at 3, but all the other points is continuous, okay, because no jumps or graph. But if you check a limit, for example, if I check at 2, no, if I, this is not continuous at 3, it continuous all the other points, okay, because if I look at here 2, for example, I can say limit x goes to 2 negative fx equals 1 to limit x goes to 2 plus fx also 1, no, and f of 2 first I have to check this, that is also 1, because these two are equal, limit x goes to 2 fx also 1, no, so they are same. I trust to, because even here we can tell that, but I cannot ask you because this value is not true, you cannot tell the value නේ. මේක දෙකේ ගත්තොත් උදාහරණයක් ඇටියට මේ ඔක්කොම එකයි continuous නේ. දෙකේදී මේ මෙහෙන් ආවත් එන්නේ එකට, මෙහෙන් ආවත් එන්නේ එකට, ඊළඟට f දෙකත් එකයි, ඔක්කොම එකයි. මෙතෙන්දි මට මේ වගේදි continuous, මට මේ value එක ඔයගොල්ලන්ට කියන්න බැරි හින්දා අහන්න බෑ ප්‍රශ්නයක් ඇටියට. But if I look at 2, you can see, no, මෙතෙන්දි මේ value here you cannot see exact what value, but it's continuous. Okay, so for example this 2 all goes to 1, no, function value 1. Okay, good. Okay, so now if do you have any other questions? Otherwise I'll go for that factoring worksheet. Okay, okay, let me. Okay, I will upload the next lecture notes today because I add some additional parts because people doing physics and chemistry also join. Okay, මම පොඩ්ඩක් additional ටිකක් add කරනවා. ඒකට මම අද රාත්‍රියට upload කරන්න lecture notes 2 එකගේ. Okay, ඒක තමයි තියෙන්නේ අද කතා කරපුවා lecture note වල. ඒක මම upload කරන්න. දැනට කතා කරපු ටික තියෙනවා ඒක අර typo එක හදාගන්න lecture note 2. So the lecture note is that what I discussed today, correct that typo x equals 2 thing. I will upload the corrected one sometime today, okay, by night. You can check. So is there any questions you want help with this factoring? මේ factoring එකේ මොනවා හරි ප්‍රශ්න තියෙනවද? Oh, let me share the screen. Okay, do you have any questions you want me to discuss in this factoring? I think I skip example 5, thinking you can do it, but okay, 6, number 2. Example 6, question number 2. Okay, example 6, question number 2. Okay, 2C, okay. Oh, okay. So this 2C, x to the 4 minus y to the 12. Okay. So here it's going to be x to the 4 minus y 12. Can you see the whiteboard board? Okay, yeah, you cannot see. No? Let me share. Let's go. Okay. Can you see the board now?
Yes, sir.
Okay, thank you. Okay. So here there are two parts. First, always we try to do the difference of square. When you have two ones, you can do either one of these three rules. No. Okay. Out of these two, first always you try to go for the difference of a square normally. Okay. So unless there is a specific reason. Okay. So here I can write this as a difference of a square. I need to have a square here. So that means I have to divide 4 by 2. Here I get x to the square to the times 2. Okay. Minus now 12. I need a square outside. You multiply this number to get 12. No? මම මෙතන මේ ලියන එක මෙතන තියෙන එක multiply කරාම 12 එන්න ඕන මෙහෙම ලියවම no. So it should be 6. Okay. So you get this. Now this is my A. Okay. This is my B. The formula I'm using difference of square. See. Okay. That is A minus B. A plus B. No. Okay. So here A is x squared now. No. When you compare this square get compared with this square with this. Okay. So you do A minus B. Okay. X squared minus y to the 6. Okay. And x squared plus y to the 6. Okay. Then this is the first step. Okay. You come back and see whether there are any way to factor further. Okay. So this one, again you can write it as a difference of a square. No. 3 to the square. Okay. If you look here, there is no sum of squared formula, only difference of square. Okay. See, for the square. So this one I don't have anything. Okay. Or if you want actually, yeah, no, because this is a square. Okay. So here this is a square. I cannot break it down. So I write like this. Okay. Now this one, this x is A this time. This y3 is B. So I can do x squared minus y3 sorry, not x squared x, no, because my x A is x now. X minus y3 x plus y3. Okay. So this one will become x squared plus y6. Okay. this one I cannot further factor, so here I stop. Okay, is that clear? Okay. Okay, example 6, question 3, part D. Let's see, I think. Oh, yeah, okay, this one, what you do, let me check whether I right. Negative, give me a minute, okay, to see whether, okay, can I divide it by 3? Okay, first I can take a common factor, no? Let's see, okay, I wonder whether there is typo in this one, but if I will do a similar one if there is a typo. Let's see. Okay, 12x4 minus 3x squared minus 54. Okay, minus 3x squared plus 54. Okay, so I think 3 is common. Okay, if you got here, I get 4 x to the 4 minus x squared.
Excuse me, sir. It's at minus 54.
Oh, minus. Okay, good. Thank you. Okay, minus is this 3 is common. Let's see. 3. Let me check. First, we check for a common factor. 54. Okay, now I need to divide 54. No, it's not common. Okay, here there is nothing. Okay, not common. So you need to find the factoring. Okay, so the way to do this, first you convert it to a quadratic question. Okay, we'll see whether if this middle term, I'm not sure whether I made it, whether I have a typo there or not. 4 times 3 to get. So first one, okay, I'll do a easier version first. Okay, this the something like this, then I'll go for that. Okay, because mainly I wanted to explain is this one, x to the 4, something like this. Let's say 5x squared. Okay, first I will do this and then I'll explain that. Okay, because this is the main concept I want you to learn from that. Okay, let's say I want to do this one. So this is, there is nothing common here. There are 3 terms. So I can use that middle term method you learn here. Okay, you can use this one. X squared plus 5x plus 6, something like this. But here I have x to the 4 here. But this is a half of x to the 4. Okay, so if this question is half of here, I can use this method. So what I do, I will say t is some y. Okay, let's say y is equal to the x square. Okay, then x to the 4 is equal to what? Y square times square. Okay, that is, sorry, x square times square y squared. No, this is, I can write x square times square, that is x squared is y squared. No, so what I do for this one, I plugging in y to the 4, sorry, y to the 2. No, now y to the 2 plus y squared plus 6. No, so the middle term 5, now I can break it down to y squared plus, this is 3, no, because I get y and y, sorry, not y squared, y here, y 3 and 2. No, if you add them you get 5, but now y is x squared. No, so here x squared plus 3 and x squared plus 2. Okay, and there is, I cannot, then I have to check whether I can further factor this is a different sum of a square, I cannot further factor. No, sum of a square is not, so I plug that x squared. Okay, is this clear? The one I did, is that clear? First I'll go for that part D, question 6 part D next. Is this fine? Okay, so I use this. Okay, good. Okay, so now what we do, this can work anywhere. This is half. For example, let's say x to the, I had here 6 plus 5y cube plus 6. Still I can do, no, I can say this is y cube is x square, x now. Sorry, x cube is y, no, x cube is y. Then this is y squared, no, because then x to the 6 is equal to what? X to the 3 times square, that is y to the square. Okay, so I can say y squared plus 5y plus 6. Again I can go y plus 2. Okay, y plus 3, then y is x cube. Now x cube plus 2, x cube plus 3. Then here I can use cube, sum of cube. Okay, I will not do that because I think you can do that. Oh, no, I cannot do sum of cube because 2 and 3, not cube. No, 2 and 3 I cannot write as a cube. So I stop here. මේක මෙතනින් නවත්තනවා, මොකද මේ cube එක දාන්න බෑ, මේක cube එකක් හැටියට ලියන්න බැරි හින්දා. Okay, so now we will go for that question 12x guy. Okay, so 12x to the 4 minus 54. So I say x squared is y is equal to x squared. Okay, so here I get 12x squared minus, not 12x squared, 12y squared, no, minus 3y Okay. Now I need to get A, B, and C. Now I am going to use this method. Okay, if you can factor in mind, you can do it. Now we are going to use this method. Okay, what you use for these three quadratic polynomials. Okay, so here I say A is 12, B is minus 54, no? Okay, that is step 1. Identify A, B, and C. Okay, and C is, no, sorry, B is 3, C is minus 54. Now, multiply A and C, okay? So this one 12 times 54. Or any, no common factor. No, 12 times, oh sorry. 648. Okay, now that's, I think I made a
3 is common.
sorry,
The 3 is common.
3 is common. Okay, good. Let's see, then it's fine. I didn't, maybe 3, 12, 4, no? Otherwise, 4y is y. What is 54 divided by 3?
18.
Okay, 18. No, sorry. Oh, yeah, I was going to do that. Then I thought it's, sorry. Okay, now it's fine. Now I can multiply this 4 and 80. Okay, this is, I do that y squared here. A is 4, B is minus 80. No, B is minus 1, C is minus 18. Okay, so I multiply A times C. If you can do this in mind, you can. Some people might be able to. I need to see this on these type of things. Okay, so C, that is 4 times minus 18. I get 32. 3 left. 4 times 4 plus negative 72. No. Now I need to find the factor of pair of negative 72 to give this negative 1. Okay, so 72, I need to factor it.
9 into 8.
9 and 12, very good. Okay, thank you. 9 and 12 is 72, no? One of them I have to make negative. Yeah, I will make 12 negative, no? Because I need, okay, okay, 9 and 12 is 72. Let's see. But it
So it's
don't give
9
negative.
and 8.
Sorry?
9 and 8.
Oh, very good. 9 and 8 is 72. And I will use negative 9 here because to give that one. Okay. Thank you. Because I'm very not good with when multiplying things and this stuff. Okay. So 4y squared. This middle term I break 9y plus 8y minus 18. Okay. So here I'll have to, if I do this, there is nothing common here, so I flip this. Okay, this is that fourth term method we learned. I flip this, I get plus 8y minus 9y. Okay, why I flip? Now I can pull out the 4 common here, and y, here I get y plus 2. This is that 4 third. Here I have to put negative, no? Negative 9, I get y plus 2. Okay, so this is y plus 2 and y plus 2, that is common. If you need further on this one, I can go on next time again because so now y plus 2 is common. Okay, I pull it out. Here I get 4y minus 9 is left. No, Okay, so this finally it is this, no, y plus 2, 4y minus 9, and then I can replace this y by x squared. So x squared plus 2, okay, 4x squared minus 9. Okay, I'll go over this method again if you want to next time, because I just little bit. Okay, so this is the way. So key idea I wanted to you learn is to use this x squared. Okay, then middle term method, I know some people should be able to factor it in mind like this. That's fine. There are shortcuts. Okay, you don't have to use. So from here to here, actually there are shortcuts method to come here. Okay, you can use that directly. It doesn't. You don't have to do these middle steps if you can do it in mind. Okay. So are there any other questions? If you want, I'll check this next time again. Okay, good. Okay. So are there any other questions from the worksheet 4? Otherwise, we'll stop. I will upload the recording, and also I will upload the lecture notes to part by tonight. Okay, you can read it for the next time, but I upload it tonight. I have to add that some additional questions. Okay, so if you have any question, you can ask me. Otherwise, you can log out. Okay.
Thank you, sir.
This worksheet, there are no YouTube links. I will try to create some, but I was little busy, but I have the lecture for this worksheet. Okay. Okay, welcome. Okay, I'll stop now. If you have any questions, you can ask me. Okay, welcome. Okay, for recordings, I'm uploading them as lectures in LMS. I put a YouTube link in LMS. Okay, to go to lecture recording, go to the LMS course, and there is a section says lectures. Okay, there you can find the recording. So okay, lecture recordings YouTube LMS එකේ තියෙනවා link එකක්. Okay, LMS I have to break it to separate files, so I keep applying for it. Also, I make some of them public. Okay, welcome. Okay, I'll welcome. Okay, so I'll stop the lecture. Okay, if you have any questions, you can. Okay, 4 to, let's see. Oh yes, this one you can further factor, because yeah, sorry, I was, you can further factor it very good. Okay, 2x I was, because this is 2x squared, no, very good. Okay, minus 3x squared. So this one I can do 2x plus 3 and 2x minus 3. Thank you. Okay, I was little bit tired of that. So thank you. Okay, yeah, good. Okay.
Okay, thank you, sir.
Okay, welcome.
Thank you,
Good.
sir.
Okay. Okay, welcome. Okay, I will stop now. Okay, welcome. Okay, I'll stop now.